Oh, hello everyone, Mr. Fritz here. In this series of videos, we're going to talk about how to graph the sine curve. This is a pretty exciting graph, one of my personal favorites, so let's jump right in and figure out how to graph this thing. So what I want to start off with first is what the parent function is. This is the function from which all other functions come from. So all the other functions are like the child functions, but this one is the parent function. We want to graph the equation y equals sine of theta. So we're going to use the unit circle as a guide, and we're going to fill in this table right here, and then we're going to use that table to plot what this thing actually looks like. It's kind of a mystery. Let's see if we can generate the graph. So one thing I want to remember is if I'm taking an angle theta, and I'm kind of rotating an angle around, let's just write down what those unit circle values are. And I'm just going to highlight the four quadrants. Let's stay in radians. So I've got 0 radians over there. I've got pi over 2 radians. Over here I've got pi radians, and I've got 3 pi over 2. And then of course this continues to repeat, 2 pi and so on and so forth. 5 pi over 2, we can keep going. Let's think about if I were to back this up, wind it the other way, and if I were to look for the angle negative 2 pi, what would that y value be in my graph? Or what would the value be of the sine of negative 2 pi? So I'm looking for the y value in my unit circle. So if I wind this back full rotation, that's negative 2 pi, and the y value of this coordinate is 0. So the sine of negative 2 pi is 0. If I were to get negative 3 pi over 2, if I were to plug that in for theta, then I'm going to kind of wind this back 3/4 of a turn, and that's going to be negative 3 pi over 2. I'll write negative 3 pi over 2 over here as well. So that's wound back here. And that y value of this coordinate is 1. And then at negative pi, that's going to be this angle right here. This is negative pi. So the y value here is 0. If I go another 1/4 of a turn in the counterclockwise direction, this is the same angle as negative pi over 2. If I start from here at 0, go a 1/4 turn, it's negative pi over 2. The y value here is negative 1. And let's keep going with that pattern. So actually I'm going to keep going in intervals of pi over 2. So my next theta will be 0, then I'll have pi over 2, then I'll have pi, and then I'll have 3 pi over 2, and then finally 2 pi. Okay, and let's keep filling things out here. All right, actually I'm just going to fix the zoom to look like this. And so here I fit all of my theta values. And let's keep going around the circle. So when I look for the sine of 0, that's the y value here on the unit circle. So that's 0. Pi over 2, that's the y value up here. That's positive 1. At pi radians, that's over here. The y value is 0. Keep rotating. The y value here is negative 1. And then finally back up to 0. So I want to take these values and I'll plug them in on my xy plane here. Excuse me. So what I'm going to do is I'm going to label my graph, my y-axis. Let's say that it's 1 every 2 boxes. So we can label that as 1, 2, and negative 1 and negative 2. And I'd like to fit this entire table on here. In order to do that, I'm going to have to try and chunk, let's see, all these positive values from 0 to 2 pi. I've got 1, 2, 3, 4 things to sandwich in the positive side. So what I'm going to do is I can actually spread this out. Every 2 ticks can be one of these intervals. And oh, let me go back to blue actually. And so I'll say that this is pi over 2 radians, this is pi radians, this is 3 pi over 2, and this is 2 pi radians. Going to the left, that's going to make this one a negative pi over 2. Another 2 boxes is negative pi, another 2 boxes is negative 3 pi over 2, and finally it's negative 2 pi. And maybe what I should do is actually let's label what these axes are. So I'll go purple here for this. And my y-axis represents my y values, and my x-axis represents theta. So just to keep track of what's going on here. Now let's plot all of these points. So I'll go back to red here for this. Let's start with negative 2 pi and 0. So when theta is negative 2 pi, y is 0. When theta is negative 3 pi over 2, y is 1. When theta is negative pi, y is 0. When theta is negative pi over 2, y is negative 1. And we back up to 0. And we have a little bit of a pattern. Then we go all the way up, then we hit the middle, then we go down, and then we go up. And so if we make a smooth curve to kind of connect this, it looks something like this. And I'm going to put some arrows on this because it does keep going on forever and ever and ever. But this is the sine function. This is the parent function. This is y equals sine of theta. Now that you know what the sine graph looks like with these ups and downs and maxes and mins, you can now do the sine dance. There it is. Good stuff. Okay, now you know. All right, so let's talk a little bit about what the sine function has as far as properties. We can describe things with this sine function. I want to talk about the big four. There's lots of properties I can talk about with this function, but let's talk about four right now. The domain, remember, is all of your possible x values, and this is going to continue to go on forever in both directions. So the domain here is going to be from negative infinity to infinity. And then the range, that's all of my y values, and that's going to go from positive, or rather negative 1 up to positive 1. There's my range. So I can say this is negative 1 to 1. My period, this is kind of a new term. This is basically the starting point, the time that it takes from my starting point to the ending point of one of my, my waves of this function. So if you can kind of see, I'll grab a point on this function right here, and I want to know how long does it take to get back to where I started. And that's going to end right here. This is one period. And you can actually trace any point to its analogous point in the next wave. So I could actually take one of the peaks or crests of this wave and trace it until I get to another crest, and that's really the same distance. That's one period. And I can count how long that is on my x-axis. So from 0 to 2 pi is my period. That's how long it takes to repeat, so that is my period there. And then finally, let's take a look at the amplitude. That is the distance from the middle of my graph to the highest point. And it looks like in this graph, I go from 0 to 1. So my amplitude is equal to just 1 unit in this graph. So up next, we're going to actually do some stuff with this graph, but it's a good start. And now you know the parent sine function.